Okay, so hello everyone, welcome. Can you hear me? Okay, thank you. Just waiting 1 minute, then we'll start. Okay, so we will start today's session. So basically, today is our fifth number days, and I hope already all of you get all of recorded class and also get that all of practice code. So after completing the 3 hours live training program, then you also talk about the problem solving for the previous classes. So let me share my screen. Okay, can you see my screen? Is it visible?
Yes, sir.
Okay, thank you. So let's start. So basically today's session I discuss about that air quality monitoring. So different types of air quality parameters, how we can easily monitor using remote sensing technique and also use the remotely sensed data. We also discuss about that Sentinel 5V, Tropomi, this type of satellite imagery. How to download air quality parameters time series data. So different types of air quality parameters such as nitrogen dioxide, sulfur dioxide, methane, or aerosol. We also discuss about that. We also talk about that time series chart, how we can easily make the time series chart, and how to calculate the total emission for any gases for a specific region for a specific time. What is the total? Calculate the total emission. We also discuss about that aerosol optical depth, mainly AOD, how we can easily monitor, or particulate matter 2.5, how we can easily monitor using remote sensing technique. We also discuss about that, as well as we also discuss about that how we can easily use the ArcMap, mainly ArcGIS tool, to make the map after creating the GOT file download from Google Earth Engine. We also discuss about that, and how we can easily check the accuracy of our land for map air quality parameters map, and how to extract the points pixel values for a specific geolocation. It's very important because when you want to check the accuracy, then we need to compare the data from our satellite imagery as well as also ground truth data. Okay, so ground truth data we can easily find out from our GPS value. Simply visit your study and take the ground truth data, and from the satellite data we can easily access from the satellite imagery. Okay, after creating the map, suppose nitrogen dioxide, sulfur dioxide, or any map we can easily get for geolocation. From the geolocation we can simply extract the pixel value, then further we can easily check the accuracy. We also discuss about the trend analysis, how we can easily check the trend analysis, and how to apply the linear regression model. Okay, in for different purpose we use the linear regression model. So I'll show you the one example how we can easily use the linear regression model and also work with Google Earth Engine. So let's go one by one. I try to discuss about all of details. Let me open my slide. So first of all, here you can see this is the two map. One map for the methane concentration map of Kuwait. Another is the nitrogen dioxide concentration map in Bangladesh, year of 2020 January. Basically, this type of map simply we download it as a GOT file format from Google Earth Engine after completing the analysis. Okay. after filtering all of those, just simply download the GeoTIFF file format, and further we can easily create this type of map using ArcMap or QGIS software just for our research paper or presentation. So this type of map how we can easily create, I also show you this for today's session also using ArcMap. And also you can see this is another so this same process, but in this case we'll just make the classification, okay, for the different time period. For classification, suppose very low concentration, low, medium, high, very high. So this type of classification we can easily do using ArcMap. So I'll also show you this process also how we can easily make the classification. So basically air quality monitoring, in this case we are just using one satellite, mainly it's a Sentinel 5P satellite. It focuses on air quality and composition climate interaction with main data products being ozone, nitrogen dioxide, sulfur dioxide, formaldehyde, aerosol, carbon monoxide, methane. So this type of gases we can easily access or trace from this satellite imagery, and this is the link about that. So simply visit the link, you can easily access all of dataset, mainly Sentinel 5P dataset. Or if you want, simply open your code editor. Okay, so let me open new code editor, and from the code editor just go to the browse data catalog. Then we can easily access all of data easily. Click on the Sentinel, and from the Sentinel just click on Sentinel 5P tropospheric instrument. So from this Sentinel 5 we can easily access all of air quality products such as aerosol index or cloud. Also you can see the carbon monoxide, formaldehyde, nitrogen dioxide, ozone, methane, sulfur dioxide. Okay, but this type of product we find out that two types data. One is the offline, another is the near real time. Offline and near real time. Okay, basically near real time provide you more update data. When you click on the near real time we can get the more update data, and offline is not more up mainly 2 days or 3 days before that we can get from the offline data set. Just click on the near real time. So now you can get that, you can see near real time nitrogen dioxide data. We find out the data from year of 2024 27 December. Okay, we can find out that 27 December. But when you check the offline data, okay, let me open again. Just click on the Sentinel 5P tropomy. So just click on the offline. So from the offline we find out the data 18 December. Okay, so two types data we are use. So basically offline nitrogen dioxide or offline data set is we find out the more better visualization than the near real time. Okay, and also get the more better result when you want to use the offline nitrogen dioxide or offline any offline data. When I use, then you also get the more better, but processing is the same. So you can see the carbon monoxide, formaldehyde, nitrogen dioxide, ozone. Okay, all of data are the offline and near real time. Only one data, methane is only available for the offline. It's not available for the near real time, it's not available, but otherwise all of data we can easily find out the two types data, offline or near real time data for all of gases. Okay, so randomly I show you one data set. Suppose I want to work for the nitrogen dioxide. You also try to follow the same process for other gases also because it is similar. Okay, just click on, suppose I want to check for near real time, just click on here, and we find out the data between this is the last time period, 27 December 2024. Okay, so now in this data set we find out that all of description from here how they create the data. Okay, and also get the bands. So basically you can see different types of band. First band is the nitrogen column number density. So when you calculate the density of nitrogen dioxide, then we have to use this band, and this band unit is the mole per meter square. Okay, we can easily convert this unit micromole or ton. We can easily convert. Further I will show you that how we can easily convert the unit. And also you can see the tropospheric phase, nitrogen column density, stratospheric phase. Okay, so now this is the data, and this is the description. You can easily get all of information how they create this type of data. We can easily get it from here. So now I want to use the data and work for my specific boundary. Further we try to develop suppose I want to check for the trend. What is the trend for nitrogen dioxide for Dhaka city or Bangladesh? We try to check the trend. It's increasing day by day or decreasing day by day. So this type of information you can easily visualize from here. So first of all, just simply import the dataset on your code editor. Just copy this snippet from here and then paste on code editor. Further, just give a variable name for storing the data. Suppose I put the name for suppose dataset. Okay, dataset. Okay, so just I put this variable name dataset, and this image collection a lot of band, but I want to work for a specific band. Suppose I want to calculate suppose density of nitrogen dioxide. So just I choose for the first band. Just copy the band name also from here. Just copy and then select this specific band. Just put here the select function and put this band name. Okay, so now I want to check for near real-time data. Okay, and update time is the 27 December. We find out today is 28 December. Okay, so we try to check it. So for that, just put here the filter date. Suppose I want to monitor the near real time from year of 2024. Suppose December, first is December. Suppose from year of 2024. Suppose December 27. Or I want to check for suppose last 7 days data. Okay, so anytime period you can simply select in here. So now first of all you need to check how much image is available in your collection. Okay, so for that just print this dataset, print dataset, and use the size function. So now it computing how much images are available in your collection. So just run the code. We find out that this is the total size. We find out 1259 images are available. So now I want to suppose I want to make the time series chart and check the trend for this 7 days. What is the trend? Okay, so basically when you want to make the trend analysis, then we need to take the more data set. Okay, if your data is more or big data set, we can easily find out the trend. So when you check the trend, you try to take the increase your time period. Okay, then you also get the more better trend analysis. Okay, so I'll show you that. So now I want to check suppose time series chart for this data. So for the we already know about this code chart, UI chart, image dot series. So we already know about the code because we already use it for making the time series chart. So I simply search this function in here, UI dot chart dot image dot series. So just so this function. Okay, so I want to import all of function, all of argument together. So for that just simply click on the arrow sign, just click on here. So now it automatically create a dictionary. Mainly you can see curly bracket start and curly bracket end. So and also put the keyword. Okay, so now just I put here the key value. Okay, so first keyword is the image collection. Okay, so in this case I want to work for total 1259 image collection, and this image collection is stored variable name is dataset. Just copy this variable name dataset and then paste here. Okay, so then region, it's your specific boundary, which area you want to create for this. Suppose I want to create for this object, for that suppose whole country boundary of Bangladesh. Okay, just import. I put the import the whole district boundary shapefile and I put the name suppose ry. You can put any name as a variable, and further I define my region of interest, it's ROI. Then reducer. So now how I can reduce, it's an statistical argument. Suppose you calculate for maximum or minimum concentration or average concentration, just mention in here. I want to calculate suppose average. Just put here ee dot reducer dot mean, and further also scale. Scale means resolution of your satellite imagery. So this resolution is that 1113.2 meter. Just mention in here 1113.2 meter. And X property default we are using here system time start. System time start. So now uncheck this type of command line. Just remove. So now this whole thing just store it in a variable. So just I put a variable name, suppose chart equal. Okay. So now just print the chart and now run the code. So now it's generating the chart. Okay, so we find out this type of chart, and if you check the chart properly, so you can see all time we find out that zero value, it show the null value. Okay, so this is the one kind of basic problem. So now how I can solve the problem? So basically this density is very near to the zero. Suppose inverse 10 or inverse 5. So that's why it show the round figure as a 0 when I calculate it as a mole unit. Okay, then it show this type of result. So this mole is big unit, but for my study area this value is very less. Okay, very less, near to the inverse. So that's why we find out that 0, it show the round figure as a 0. So now how I can solve the problem? So in this case, if you just simply convert the unit, then we can easily find out this type of value. Okay, so now present time my unit is mole per meter square, and when I calculate the mole per meter square, it show the result very near to the 0. Okay, so very less value we find out. So but when I convert this mole into micromole, I want to calculate this time series chart as a micromole, then we can get the value. So when you face this type of problem, then you try to just convert the unit in micromole, then we can easily find out the value. Otherwise it show this type of null value, mainly 0. Because it show the 0, this reason is that mole is work very well for the big number, but in this case my study area this density is very less, so that's why it show the round figure as a 0. But when I convert the mole into micromole, then we find out the value. So now how I can convert the unit? So let's go try to discuss about that. So converting the unit, I simply search on the Google, suppose mole to micromole. So in this case, we find out that just multiply the amount of substance value. So when you just simply multiply this value, okay, with your mole result, then it convert as a micromole unit. So now this value I simply multiply all of images, and further I want to make the time series chart and then check what happened. So this is the formula: multiply the amount of the substance value. 1 is 6 plus mainly this value. So we try to do it. So let's go. Otherwise it show the null value all time, show the 0 if you don't convert the unit. So let's go try to do it. So for in this case I want to multiply, basically I want to multiply because we find out the total image 1259. So this 1259 images, all of images I need to multiply with this value. Okay, so now just we are using here the concept of function. We already know about that, lot of time we already use for the function. So just create a function, and this function simply multiply with our value, then it automatically multiply all of images at the same time. Okay, So if you want, you can simply use the single variable. Just I use the single variable and then connecting. Just I create the function, and this function simply connect with my collection. In this case, it's 1259. This is my image collection. So let's go try to create a function, and this function simply connect with our collection and use the single variable. If you want, you can also take the another variable. Suppose I just create a variable for a function, and then I simply connect this collection. It also possible. Okay, so let's go try to create a function. So for this function, just use the function keyword and take the element name img, and in this curly bracket, just I put my argument. So my argument is that I want to multiply this element, this value. Okay, basically I want to multiply with this value. So let's go. For that, write the code, return this image, multiply this value. Okay, and now it just multiply only for the one image, but I want to multiply all of images. Which image is available between this time period, 20 December to 27 December? All of images I want to multiply. So for that, just use the function copy properties, this image, and apply system time start to system time end. So now this is a function. Okay, so this function now need to connect with my image collection. So this is my image collection, and I want to do it, just use a single variable. Okay, if you want, you can just write the code, just write the code of function, and this code simply store it in a variable and then further connect. But in this case, I want to use a single variable, and at the same time I just connect. So for that, just use here the dot map function and put the parenthesis, then simply remove it, and then put this, close this parenthesis. So now this variable dataset is connecting, okay, with my function, and this function help me to multiply this value all of images, mainly 1259 at the same time it multiply. So now let's check what happen if I run the code. So now let's check the value again. Just open the chart, and if we check it, we find out the value. Okay, and now this unit is micromole per meter square. We find out that all of values. Okay, and further you can simply download the CSV file as a Excel format. Okay, just simply convert the unit, then we can easily get this result. Okay, anyone any question about that, you can ask me please. Okay, if you want,
So
suppose,
if I
yeah,
want to
please,
do,
please, yeah, continue.
so if I want to do seasonal variations like the four season, fall, spring, winter, and summer, and I want to show in the same chart. So how can I do it?
Okay, for that we need to create the individual image collection. Suppose for the spring or winter, just simply create this image collection. Okay, and then you want to represent it one chart, it also possible. Okay, just simply put this your suppose total 4 season or 3 season, just create the individual image collection. Okay, using this individual, suppose this I create for it, suppose summer, then suppose winter, same process, just simply change the variable name and also change the time period. Okay, then all of image collection simply merge. Okay, simply merge all of image collection together. Suppose I have total 3 season, so just I create the image collection for 3 season. Okay, and further just simply merge and store it in one variable, then create this time series chart, same process, just simply call this main variable. Suppose I take a variable, it's my final data set. Okay, this final data set combine summer, rain, or spring, or any all of season, all of collection you content, just merge and then make the time series chart. Okay, it also possible. So you also try. Further face any problem, then I'll also show you the how we can easily get it. Okay.
So for different years, so how can I do like the data set for the different years, like for 5 years, for the 5 years of summer, for the 5 years of
Okay, so
winter,
further we have to use
fall.
this function. Suppose calendar range, you can simply put the calendar range, you define your start date and end date. Suppose you can see. Okay, so just we define this calendar range also. Suppose in this case I just apply this calendar range. Suppose I need the data, suppose I need the data only for month of January, from 2000 to 2024, just I take only for the 1 month or a specific season. Okay, then we need to define this filter dot calendar range, and then we put our start date and end date and fill the field. Okay, field mainly you can simply mention your month, year, month, or hour, or minute. Okay, basically we are just used for year or month, so these things simply mention in here. Okay, let me show the one example, just a minute. And now put here suppose start. In this case, suppose I take the data from 2000, suppose 2017, from 2024, just I define here, and further, so it's my all of image collection, all of images between this time. But now I also need to filter for a specific month or a specific year. So for that, just I simply mention here, suppose start, I put here start year, suppose 2017, then put here in year, suppose 2000, suppose 2020. Okay, and put here suppose month. So now let's check what happened. Okay, I think, let me check. Oh, sorry, I need just commenting this.
What? You have to. Oh, I don't know. I
Okay,
think you're
okay, so
just
kindly
right.
mute.
Isn't that marvelous? Sir, I think data is only available from 2018, sir.
Okay, 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 thank you. Just a minute. Okay. Okay, suppose this is my collection. We find out the collection, but now I want to filter it for a specific season. Okay, for a specific year. So for that, first of all, we need to define the time range for the season. Okay, so let's go try to show you the describe this idea. Just a minute. So just take a variable. Suppose I put the variable is that start month, and in this statement simply we define, suppose you need the data, suppose June to August or January to May or any specific season. Suppose for the June we define it's January, February, March, 6 for June, and then we take the another variable, suppose in month I define, suppose August, suppose 8. Okay, so now I need the result between this time. Okay, from year of 2000 to 2018 to 2024, I need the result from June to August. Okay, so this is my main target. So now after doing these things, I will now filter the collection for image capture in the your desired season, suppose June to August. So for filtering these things, we just take a variable. Suppose I take a variable name, any name. I put the name, suppose image collection. Okay. So now I just filter my collection. So just I call my dataset because it's my full dataset, but I don't need for all of data. I need for a specific range, a specific season. So I define my start month and in month. Further, I just call this dataset. In this data, I just apply the calendar range function. Okay, so just put here the filter, and how I can filter. I want to apply Earth Engine filter dot calendar calendar range calendar range. Okay, so now I define here, just define here start month and in month. Suppose this is my start month, just copy and then paste here, and then I put here the in month, just I copy this in month and paste here. Okay, and now further just put the unit. Okay, just put the unit, suppose I put the unit for just month. So now what happened, so when I just use the code, this variable store it only for those images which images are available from 2018 to 2024 between this time period, mainly June to August. Okay, June to August. So if you check how much image is available for that, just use at the print and then call the image collection and put at the size function. So now it computing how much images are available only June to August between the year 2018 to 2024. Okay, computing. So we find out this number of images is available only for June to August, but I don't need for the whole year 2018 to 2024. I need for a specific month or specific year. Suppose I want to filter it for a specific year, so it also possible. So for that, simply change the unit. Okay, change the unit. Suppose I need this data in year of 2024. Just take a variable. Suppose I define the year I need the data, not all of year. I need the data only for 2024. Okay, 2024 between this time, mainly 6 to 8. Okay, 6 to 8, mainly June to August. I need the data in year of 2024. So for that, just take a variable. Suppose I put the variable name is that image, suppose a specific year. You can put any name as a variable, and further just use this image collection. Okay, because in this case I need between this time only for the year of 2024. Okay, so just I call this image collection and then apply the same function filter and use here earth engine dot filter dot calendar range. Okay, so in this case I already defined the year because my start year and end year is the same. Okay, 2024, I need the result 2024 June to August. So just I define the year comma and also define the year because my start date end date same. Okay, and also unit is the year. So now I get only for this image which image is available June to August in year of 2024. So now let's check, just print the image specific year. Okay, and then it has a size and run the code. Okay, so now it's computing how much image is available only June to August in year of 2024. Okay, so this is the process for filtering. Using this process you can filter for summer season, rainy season, or any specific time period, easily filter. So basically we just call the ee.filter.calendar range and then we can easily filter. Okay, then we can easily make the time series chart about that.
Okay.
Yeah.
Okay, thank you for that. So one thing I want to know, would you show us like one chart which can like represent like at least two seasons, uh, for summer and winter?
Okay, so it is possible. Suppose for that we just make the combo chart. Combo chart mainly it's including at the same time two image collection. Suppose summer or winter. It also possible. Okay, just a minute. Okay, suppose in this case we try to make the season. Suppose this is the 6 to 8 it one season, and you also need to create the another season for the image collection. Okay, so okay, let me, I'll show you that. So for that, first of all, just I commenting and write the code properly. Just I commenting all of those, just simply comment. And now we try to make a chart, combo chart. In this combo chart we try to add, suppose from this two season, suppose summer and winter, we just try to make the time series chart at the same time for a specific geolocation or a specific boundary. So let's go try to discuss about that. So for that, just take a variable. Suppose I just filter my image collection for summer, and then just call my collection because okay, just I try to do it for year of 2024 or 2000 or 24, or I take for suppose 2023 1st January from 2023 December 31. Okay, so this is my image collection. So now this image collection is simply filter for the two season. Okay, we already know how we can easily filter. So for filtering this image collection, I suppose I take the data for summer season or dry season. just I call my collection. Basically it's my data set. So now this data set, just paste here, and I want to put here filter. I want to filter it. How I can filter? Earth engine dot filter dot calendar range, and this calendar range. So basically you find out that suppose summer, just simply define your specific month. Okay, suppose I consider the dry season from January to suppose 5. Okay, May. Okay, just I consider the May, and I put here the unit. Suppose unit is the month. Okay, so now it create the one collection. Further same process we apply. I want to create, take the another variable, suppose winter. So just call the dataset, and this dataset I want to filter. Put here Earth engine filter dot calendar range, and this calendar range I want to define for winter, suppose December to February. You just put here the December, suppose February 2, and also mention here the unit mainly month. Okay, so just to simply filter our specific season. If you check how much image is available, just simply put the print and call the summer, because it's very important. If you don't have any image, then we cannot make the chart. And also check the how much image is available for the winter, so just call the winter and use at the size. So now it computing how much images we find out. Okay, so you find out this type of result. Basically this last two result, we find out that image is available. So now we can easily make the chart, and we try to find out that combo chart. Okay, so now if you want, you can also extract the statistical value. Suppose I want to check for the summer, what is the minimum value, what is the maximum, what is the minimum value for winter and summer. It also, okay, so also discuss it also. Suppose I want to calculate for that in the summer, what is the average concentration. So for that we extract the seasonal statistical value to season. Okay, so for that just take a variable, suppose summer mean value, we calculate. So for that same process, just I call the summer image collection, but it's not mandatory. I also show you this process also, how we can easily check the value also for a specific season. So just call the summer and then apply reduce region function. You already know about it. Reduce region function mainly it calculate for a statistical value for any specific boundary, any specific polygon we can calculate. Okay, so now just put all of argument. Okay, so just I randomly write. So first argument is reducer mainly I want to apply average value, so ee dot reducer dot mean. So now it calculate the average result. Then geometry I define as a RY, it's my shapefile variable name. Then scale mainly 1113.2 meter, and further I want to apply for, okay, so it's a big study area, so I face some, okay, let me check first what happened if we face any problem. And I want to get only for value, so put here the get. Okay, I want to get the value of okay, just I print what happened and then I put the get. Just put here the print and call this summer mean value. This simply copy and paste and run the code. Oh my god. Oh sorry, we have to just, because region function is also work for that average, so we just applied for the collection, so that's why it show that summer is region is not a function, because this function is only work for a image, not collection. Okay, so just convert, just take a variable, suppose summer mean. So now I call my summer collection, just copy and paste here, and just I calculate for mean. Okay, so now I hope it will work. And okay, so just call this variable name and change it, because reduction function is only work for image, not collection. So now I can easily computing what is the value of average value. Okay, find out that one value. So we find out that 96.77. Okay, 96.77, it's a micromilliunit because we already convert. But in this case I just need only for this value, not the dictionary. We already know about that. So just put here the values and get into function. Just we put here, suppose dot get. I want to get the information from this keyword. Just copy this keyword and paste here. Just paste here. So now let's check what happened. Okay, just we can get the value only. Okay, because further we also use the value and make the chart, combo chart. Okay, after that we get the result for summer season. Same process you also apply for winter season. Just take a variable, suppose winter mean. Okay, then call this winter image collection. Just copy and calculate the average or mean. So now further just we also calculate this same. Just copy and paste. I change the variable name, suppose it's a winter mean value, and I call this winter mean image. Just copy and paste here. So now further same procedure will also apply in here. Okay, and also print the value. So print this value, winter average value. So now run the code. So it also computed the result for winter season. Okay, it's the same result. Summer mean value we printed, winter mean value we printed. Okay, why it show the same result? Okay, it's the winter mean. Okay, so this is a winter image collection equal, and then create the mean, and further we'll just use it. Okay, just call the winter mean and then calculate the statistical value. Okay, what's the problem? Okay, let me change the time period and then check. Suppose I want to put here, suppose 5 to or 6 to 12. Okay, image collection is a different image collection you find out, but it show the same value for the two season. So let me check for, suppose I want to calculate for the year. Suppose year of 2000 2020. Oh, okay, so we face the problem 2023. Okay, so let me put here, suppose 2000, change another year. It show the 89.28 same value. Let me check the last result. I think it also okay. So we try to print 3 times. Yes. So this is the one print. This is the another. This is the another. Yeah. Okay. Oh yeah. So now let's check last result. Okay. So okay, you get the variation. Okay. Sorry. So I face the problem in here. I want to just print 2 times for the summer mean value. So that's why first two value we can get the same. Okay. So now it's okay. No problem. Okay. Suppose I want to check it for year of 2023, and I put the specific month, January to 1 to 5, 6 to 12, okay, or any time period. Suppose I put here the December to February. So December, and then define here the 2 for February, and now further just same. Okay, so just I remove it because I already print in the print the bottom for the two result. Okay, summer and winter. So now let's run the code and check. So now we find out this value. So we can find out the two different values. So now it's okay. Yeah. So 96.77, we find out the result for summer, and 87.80 micromole in the winter. We find out this two value. So now we try to make the time series chart. Okay. For the two season, and then we compare. Suppose we just make the chart. This chart show the combo chart. This combo chart show the result for summer and winter. Okay, and we already know about the value. If you want, you can simply suppose 3 season, just recalculate the 3 season mean value, and then just make the graph. Okay, so let me show the graph how we can easily create. So now for showing this graph, in this case we are just need to make for feature. Okay, combine data into array. Just we make a array for the chart. Okay, so for that just take a variable, suppose data equal, and we just make a feature collection. So ee dot feature collection. This collection we need to create the feature, mainly two feature. Okay, so one feature for winter, another feature for summer. We just need to define it. So I want to create the two feature in my collection. So for creating the feature, put here ee dot feature, and this feature we need to define. So basically in this feature there is no geometry. Okay, here just create the feature with our data, there is no geometry. So for that, first just is here the null, because there is no geolocation or there is no for latitude longitude value. Just I put here the null, and now I put here the properties, mainly attribute. I set the attribute, suppose it show the season for, I define the season first one, suppose summer. Okay, and then another, it show the value. Okay, suppose I put the column name for that, it's a suppose density, and summer density, mainly it's come from the summer mean result. So summer mean value, just copy and paste here. So one feature is done, okay, for the summer. So now also take the another feature for winter. So same process, just use here the comma sign and then write the code again. Just ee dot feature, and there is no geometry, so that's why I just put here the null, and then simply put your attribute. So my attribute is that first one is season. I define the season, it's for winter, and further I put the another, suppose density is for it's come from the winter mean value. So now we get our data. Okay, so now I want to create a chart, then this chart give me the suppose bar column chart or line chart. It show the two value, one value from summer, another value from winter. So let's go try to do it. So in this case we create the chart using feature. Basically we just create the feature collection using this feature. Just I make the chart. Okay, so let's go try to search a function for feature. So I want to create the chart using feature, so simply search here chart feature. So here you can see, find out that UI chart feature by feature. Okay, so this function I need to use because I, in this case, I want to make the chart using this feature, two feature I want to use, and further I want to check. Okay, okay, so for that just import this function UI chart feature by feature, just import. So now we already define our data. Okay, so we already define our data, so just I call the by feature. So feature mainly including three item, x property, y property we need to define in here. Okay, so feature mainly it's including the data. Just I call the data, just copy this variable name and paste here, it's my feature. And further x property I want to show, suppose season, suppose it show the x column for the show for the season. So for that just I call this attribute, mainly column name, and paste here. And y properties, mainly vertical axis, it show the value. Okay, it show the value. So just I define this value, and okay, just put it the because it's a list, because this list including the two values. So for that use the square bracket, and further call this density, just copy and paste here, and further just uncheck it, it's not need, it also not need. So just the full chart, just store it in a variable and then print the chart. Okay, just call the chart and run. Let's check what happened. It's working. In this case, I take the biggest study area for the whole country boundary of Bangladesh, so that's why it takes some time. But when you work with a small area, then we can easily get the result very quickly. Let me add a small area. It takes some time, just a minute. So now run the code. Okay, we find out this type of result. Okay, so let me add the more information, just a minute. So first of all, we try to add the one information, suppose chart type. So just put here that set chart type. Okay, and now I want to put here the chart type, suppose combo chart. Set chart type. Okay, let me check. Okay, okay, sorry, it's a column chart. Okay, because I want to create the column, you can say basically three chart type of chart we can create: a scatter, line chart, or column chart. Okay, sorry, just copy this column chart. Because there is no combo chart option. Okay, just we try to create the column. Okay, but it show only for the one column. It show the summer information, but I also need to add for another information for winter. Okay, season is stored this 2 season. We call the data, this data, we just print this data and check the information. So you find out the three column, mainly density, season, and feature. Mainly only it showed only for the one feature. This one feature we find out that only for the summer. Okay, that's why you find out that one bar column show the summer result, but we need to add the two feature at the same time. Okay, so what is the problem? Okay, this problem is that we need to create the list. Okay, so we need to create the list of feature. So for listing of feature, we have to use the square bracket. Okay, square bracket start and square bracket end. So now I hope it will be work. Just put here this time. So now let's check. So just make the list. Suppose you can add more also, summer, winter, or rainy season, different time period. You can simply check, and then we find out the two chart look like that. And also check the feature. We find out the two feature. We find out that you can say 0 and 1. 0 mainly we find out that this value. We also get this type of value. Okay, so I put the column chart. You can represent it, suppose line chart, anything. Further, if you want, you can also check it. Suppose just add the more information. Suppose just put here the set options. In the set option, just put the some option for your chart look more better. Suppose just I put here first one is title. So put here the title. Suppose I put the title is that seasonal density comparison or time series chart, anything can write. So title, then put at the suppose vertical axis. I define the title. Put the title, suppose it represented that mean density. Okay, further put here horizontal axis, only x level. Just put the title. It represents suppose season, summer season, winter season, or year, anything you can write. Suppose season, and further you can also put here suppose series type. Suppose just put here that series type. We already checked the column chart. Series type, suppose I want to create for series types, suppose bar. I define the bars, mainly bar column. And further okay, let me check what happened. So we find out that bar chart and also show the density. If you want, you can also put here that series also. Suppose just I put here this one is for series, mainly two series, one and this one, two series is create. Suppose I want to put the series, just I call the suppose first series, mainly one mainly first, and I said that type. Suppose put here the type. I set the type, suppose line. So now let's check what happened. Okay, series one line is not work. Okay, legend is already okay. If you want, okay, just a minute. I think its series is applicable only for the line chart, because in this time I already defined the column chart, so that's why series is not work. Okay, and then legend is already show. Okay, suppose I put at the legend. You can define the legend position. Suppose put at the position. Put the legend top or bottom or right. Okay, suppose I put at that top. Right, so this type of chart it also possible. You can also download the data for summer season or winter season or any other season. We also try to add, but for that we have to use the new function, this function called the feature. We need to use the feature. So for the feature we need to create the null feature. Null feature means that there is no coordinate. Okay, so for the user the null, and then we just simply define the attribute. In this case attribute mainly this value, it's come from the statistical value, so that's why we also calculated the mean. Suppose you want to create the maximum, just put at the max, then you can get the result for maximum concentration for summer season or winter season, and also get this result. Okay, and this process just we simply filter for a specific season. Okay, Okay, so any question, please? And this process is also applicable for other dataset also. Okay, so when you filter and also make the time series chart, just apply the same process for seasonal. When you work seasonal, winter season, summer season, rainy season, just apply the same process also.
Okay. Would you show us like for like 5 year data set for 5 year summer, 5 year winter
Okay,
in a line chart?
okay, so okay, let me show you for line chart for this example. Suppose just click on the same.
And could you please share the code? This one later.
Yeah, all of code will be shared. Okay,
Okay,
so
thank you.
which I display in the class, all of you can easily get it in our Google Classroom. No problem. Okay, just mention here, suppose chart type, line chart. Okay, so the result error generation incompatible default series types. Okay, I think for the line chart we also need to create the another feature collection or another algorithm to create it. Okay, so for the column it also work. Suppose it is possible, suppose I create the result for suppose I just create the line, and in this line one line show for blue color, another line show for the red color. It also possible. So for that, okay, let me show you the example. Okay, basically it's the out of syllabus. Okay, you also try further. Okay, I will show you that just a minute. So how we can easily create for the line chart in our image collection for a specific. So for creating the line chart, we just apply the same approach also. Just we already create the data for summer and winter. We'll just use it, and further we define a time series reducer for each season. Okay, suppose in this case we just create this type of value, randomly create. But if you want, you can simply create a function. This function automatically calculated time series for each season. If suppose you can including summer, winter, rainy, or any season, different time season, you can easily add. Just you define, and further you can easily do it. Create a function. This function return the value. Further we are just combine this feature collection, and then just create the two feature. So this thing is also possible. We create a function, or if you want, you can just simply use the merge function. Okay, suppose just simply feature collection by merge. Okay, so I'll show you that, create a function and then show you that. Okay, so for the function, when you create, just I take a variable name, suppose get time series chart. You can put a name, get time series chart. I define the variable, and I put here okay, just put at the equal sign and define the function keyword. So in this case my argument is that I just call the image collection. Okay, so this image collection combine winter season, rainy season, summer season, or any other specific time period. Okay, as well as I also call the label mainly season. Okay, so in this case I want to take two image collection. Okay, just I take the two element in my function. I define the two element, and this two element help me to get the result, mainly two result, one result for density, another result for season. Okay, so for that just I put one element, suppose image collection. I put another I put here suppose label mainly suppose a specific season or a specific time. I take the two element. So now I want to use this two element, and further I create my argument. So in this case my argument is, okay, my argument is I want to return this image collection. This image collection mainly execute the date as well as also execute the average density. Okay, so for that, just I use here the return, just I create a function. Okay, I create a function. Further, this function I connect with my this image collection. So basically it's called that loop function. Suppose I create a function, then in the function I create the another function. So another function help me to calculate the result of date and average density or maximum density, anyone. So just I return, just I create a function. Suppose just create use at that function keyword. Okay, through the error further we also use the bracket, then it's okay, no problem. And in this function I just define the element, suppose image, and then I define my argument. It just return the two things. Suppose I take a variable date, and this date execute from my image date. Okay, another argument is that it also calculated